Welcome back to the My Computer lecture series, Learning Computer with Seeing the Beautiful Sights of Indian Bharatiya Village. Today, now I am going to talk about the types of programming error. The first one is syntax error. Syntax error occurs when the rules or syntax of a programming language are not followed. Such programs errors typically involve incorrect punctuation, incorrect word sequence, undefined terms, or misuse of terms. For example, consider a Fortran programming statement. C equals to a plus b by 2 has a syntax error. The missing closing parenthesis that should be placed in the appropriate place depending on the logic of the program. A compiler will not compile a program successfully until its programmer correct all its syntax error. The second error is logic error. Logic error occurs when we make errors in planning the program's logic or while converting the logic into program code. They cause the program to produce incorrect result or behave unexpectedly. A compiler will compile a program successfully if it is free of syntax error, even if it has one or more logic errors. Although we can execute such a program successfully, but it will not produce correct result or will not behave as expected. For example, if a Fortran instruction should be a equals to b plus c, but the programmer has coded it wrongly as a equals to b minus c, it is an example of a logic error because the program will not produce correct result. Similarly, if one has wrongly entered only 6 nines in a number instead of 8 nines as the sentinel value for roll number in the instruction for detecting the end of last record, the program will expect more records even after the last record. Testing a program. Logic errors are typically due to either missing logic or incorrect logic. If the logic is incorrect, the result obtained for the test data will be wrong. These errors are easiest of the logic errors to find. Errors caused by missing logic result from logical situations that programs did not think of while planning and writing the program. For example, let us assume that an arithmetic process uses a numeric field and the data entry operator has entered a non-numeric value in it. The program logic should determine that data is not numeric before attempting the arithmetic process. If this logic is missing, the program will fail when the arithmetic process encountered non-numeric data. This type of logical errors can be difficult to find. This error will occur only when a user enters non-numeric data in numeric field. Users may use the program for weeks, months, or even years before this happens and the error in program logic shows up. In order to test the logic of a program completely, it test data must test each logical function of the program. Hence, the selection of proper test data is important in program testing. In general, the test data selecting for testing a program should include: first, all types of possible valid data. This will ensure that the program has been correctly designed to handle all types of input data falling within the scope of the program. Second point, all types of possible invalid data such as incorrect, incomplete, or inappropriate data. This is necessary to test the error handling capabilities of the program. Good programmers should be able to produce appropriate error message for invalid data instead of hanging or generating meaningless output. Now, debugging a program for syntax error. Debugging a program for syntax error. Both syntax and logical errors are known as bugs, and process of locating and correcting this error is known as debugging. As compared to logic errors, syntax errors are much easier to locate and correct because almost all language processors detect syntax error automatically. When a language processor processes the source code of a program, it indicates on the source listing of the program each program statement having one or more syntax error and gives hints regarding the nature of the error. Programmers use this error message to rectify all syntax error in their program. Hence, it is relatively easier to detect and correct syntax error. Note that in high-level language such as Fortran and COBOL, a single error in a program often causes generation of multiple error messages by the compiler or interpreter. There are two reasons for this. One is that high-level language instructions often convert to multiple machine instructions. The other one is that symbolic instructions are often dependent upon other instructions. Hence, if a program instruction contains an error that defines a field name, all program instructions that use that field name will have an error message. The error message will indicate that a field used is not a defined name. In such cases, removal of the single error will result in the removal of all associated error messages. Now, debugging for a program for logic errors. Unlike syntax error, a computer does not produce any error message for logic errors in a program. Hence, logic errors are more difficult to locate and correct than syntax error. However, once the testing of a program indicates the presence of a logic error in it, a programmer uses one or more of the following methods to locate and correct the error. First, doing hand simulation of the program code. One approach is to take a printout of the source code of the program and go through its execution manually with the test data input that produced incorrect result. During manual execution, the programmer follows the same sequence of paths a computer would follow for the test data while keeping track of change in values of various variables that come across during the execution. Before he complete manual execution of the program, he will most likely detect the cause of the problem. This method is suitable only for simple and small programs because manual execution of a program is a tedious process. The second method is to putting print statement in the program code. In this approach, the programmer puts several print statement at appropriate location in the program so that during execution of the program, the computer prints displays values of different variables to indicate intermediate computations result. The program recompiles the program with these statement and executes it. These statement display the value of intermediate computation, telling what is happening during the execution of the program. By doing a proper analysis of the printed intermediate result, the programmer can detect the cause of the problem. The programmer removes the print or write statements from the program after correcting the detected errors and recompiles the program for future execution. The third is using a debugger. This is the most commonly used approach. Debugger is a software tool that assists a programmer in following a program's execution step by step by allowing him or her to display intermediate results. Fourth is using memory dump. Generally, programmers use this approach when the program hangs up during a test run. In this approach, a programmer prints display the concept of main memory and CPU register at the time when the programmer hangs up. This information, called memory dump or a storage dump, lists the instruction and data held in the computer's main memory and CPU register in their raw form. Their binary or equivalent hexadecimal or octal form. By doing a proper analysis of this listing, the programmer can detect the cause of the logical problem error. Testing of software containing many programs. A software system often consists of many modules, programs linked together. Such software go through unit and integrated testing process. Moreover, commercial softwares are often subjected to alpha and beta testing. These testing methodologies are described below. First, unit and integrated testing. In this testing, or unit and integrated testing, the programmer who develops a module of software tests the module independently for its functionality. Unit testing mainly verifies if a module meets its specification. On the other hand, when the team integrates the independently developed and tested modules into a complete system, the team then tests the integrated system to check if all modules coordinate properly with each other and the system as a whole behaves as per the specifications. This is known as integrated testing. The software is ready for release after completion of the integrated testing. Now, second one is alpha and beta testing. After completion of integrated testing, the team releases the software for further testing to a very selected user group within or outside the organization. This group tests the software by using if they are its users. This released version of the software is known as alpha version, and test conducted on it is called alpha testing. If the software is to be sold commercially, instead of releasing it directly in the commercial market after alpha testing, the team sometimes release it for additional testing to selected set of users such as long-time customers, partner agencies, and at times put for download and trial by anyone. This release version of the software is known as beta version. This selected set of users use the beta version of the software for an identified period and report any bug found in the software to the company developing the software. The user of beta version of the software by the selected set of users for additional testing is known as beta testing. After beta testing, the team fixes the reported bugs and then company releases the software to commercial market. Note that even at this stage, the software may contain some errors. Now, difference between testing and debugging. Since both testing and debugging deal with program errors, people often confuse between these two terms. Note that testing and debugging are two separate tasks. For example, testing is the process of evaluating the correctness of a program. Its objective is to demonstrate that the program meets its design specification. And debugging is the process of eliminating errors in a program, and its objective is to detect the cause of error and remove known errors in the program. Testing is a definable process that can and should be planned and scheduled properly. Debugging, being a reactive process, cannot be planned ahead of time. It is carried out whenever errors are detected in a program. Testing is complete when all desired verification against specifications are completed. Debugging is complete when all known errors in the programs are fixed. Note that debugging process ends only temporarily because it restarts whenever new errors are detected in the program. Last one, testing can begin in the early stage of software development. All the test runs of a program are carried out only after the program is coded, but the decision of what to test, how to test, and with what kind of data to test can and should be done before the coding is started. While debugging can begin only after the program is ready, the approach used for debugging depends largely on the personal choice of a programmer and the type of error in the program. Now documentation, software documentation. Documentation is the process of collecting, organizing, storing and maintaining a complete historical record of program and other documentation used or prepared during the different phases of the life cycle of software. Without proper documentation of software, the software industry does not consider it complete. In fact, documentation is an ongoing process that starts as early as in the study phase of the software and continues until its implementation and operation phase. Moreover, documentation is a never-ending process throughout the life of the software. The maintenance team has to carry out documentation from time to time whenever it modifies the software. Need for documentation. First, it solves the problem of indispensability of an individual for an organization. Even if the designer or programmer of the software leaves the organization, the documented knowledge remains with the organization that is useful for the continuity of the software. Next point, it makes software easier to modify and maintain in future. The key to maintenance is proper and dynamic documentation. It is easier to understand the logic of a program from documented record rather than its code. System flowchart, program flowchart or comments used within the programs prove to be very helpful in this regard. The 6 commonly used form of documentation for software are requirement specification documents, design document, comments, system manual, user manual and marketing document. They are Now let's describe this. First, requirement specification document. Before developing some software, the development team must analyze its requirements carefully and document them. Requirement specification document is an outcome of this exercise. It specifies the objective of developing the software and its usefulness to various categories of users. It also specifies the functionalities, capabilities, performance, inputs and output requirement of the software. It clearly specifies what all the software will do when. The requirement specification document is useful for a variety of purposes, such as software developers use it to define the modules, user interface, performance parameter, etc. during the design phase to meet the specified requirement. It serves as an agreement between the customer requesting development of the software and the developer on what is the scope of the software. Deployment team uses it to evaluate the deployed system against the specified requirement. Testing team uses it to do final testing of the software to test whether the software performs its stated objectives as per the specified requirements. The next, design document. Design document defines the overall architecture of the software. It specifies the various hardware and software components of the software and interfaces between the components. It includes a hierarchy of software components, rules for component selection, and interfaces between the components. A good design document provides an overview of the total system architecture and does not get into implementation details of the various components. Next, comments. Comments are natural language statements put within a program to assist anyone reading the source program listing in understanding the logic of the program. They do not contain any program logic and are ignored by a language processor. From maintenance point of view, comments are necessary. All high-level languages provide the facility to write comments in the source code of a program. Liberal use of this facility by programmers for proper documentation of their program is highly recommended. Programmers should use comments intelligently to improve the quality and understandability of a program. Comments should not be redundant, incorrect, incomplete, or written in a manner that others find difficult to understand. Now, system manual. Good software must have a standard system manual containing the following points. First, a specific module names along with their description and purpose. Second, description of the program listing and control procedures. Third, detailed system flow chart and program flow chart for each module, cross reference to program listing. Fourth, source listing of all programs with full details of all modifications made from time to time. Fifth, a specimen of all types of input-output to form software. Sixth, a specification of all input and output media required for operation of the various programs. 7. File layout, that is detailed layout of input and output record. And next point, a structure and description of all test data, test results, storage dumps, trace program printouts, etc. for testing and debugging of programs. Next is user manual. User manual describe how to use the software. Good software must have a good user manual to ensure its easy and smooth usage. It is the user, not the developers, who use the software regularly. Hence, the user manual must contain the following information. First, loading and unloading procedures. Second, installation and operational details of software. Third, starting, running and terminating procedure. Fourth, description and examples of any control statement used. Next, all console command with errors and console message, their meaning, reply and operation action. Next, list of error condition with explanation for their re-entry into the system. Next, list of program which user must execute before and after execution of each program. And last one, a special check and security measure, etc. User manual describe each feature of software in detail and make use of these features. Their commonly used ways to this are many. Software use all the three. Command function list. In this method, the user manual lists the command or function of the software alphabetically or grouped logically, often with cross-reference indexed. Each item in the list describes a command or a function in detail with example. Second, tutorials. In this method, the user manual contains tutorials for various functionalities or tasks of software, which provide a step-by-step guidance to user on how to accomplish a task by using the software. And next is online help. In this method, the user manual contains online information which users can use as and when needed while using the software without the need to refer to any other document associated with the software. This saves time and effort of users, which they would require otherwise to trace and refer to a hard copy user manual for solving problems while using the software. Now, marketing document. Marketing document serves as promotional materials for software product. Marketing personnel use it to promote the product. A marketing document consists of the following points: usefulness of the software product, its silent feature, its comparison with other competing products, its system requirement, that is hardware, operating system, etc. Now, documentation standard. There have been too many problems in the past with poorly documented software. Elimination of errors and incorporation of modifications are usually very difficult in such software, making them very expensive to maintain. Realizing the importance of software documentation, several major software organizations have developed a strict documentation standard. These standard describe in detail how to do documentation, how to choose meaningful program variable names, how to design the GUI for any software, how and up to what detail to include comments in program code, and what diagram, chart, report, output, etc. are necessary for completing documentation. Software developers and programmers working in such an organization are required to adhere to its documentation standard as stated. With this, I would like to end this lecture. So let's tell Jai Bajrangbali, Jai Hanuman Ji ki Jai ho, Jai Sri Sitaram, Jai Sitaram, Sitaram, Jai Sitaram, 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 Jai Sitaram, 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 Jai Sitaram. Om Namah Shivaya.